Alright, so now students, in this case you have Stokes theorem. You have Stokes theorem here. What does it do? You have line integral equal to surface integral. In Green's theorem, you had line integral equal to double integration. You had to prove line integral on the left hand side, and on the right hand side you had to work with double integration and show that both sides are equal. In this case, your left hand side is again line integral f dot dr, okay, and right hand side is surface integral. Now, if I want to verify Stokes theorem for this cube, which is bounded by x equal to 2, y equal to 2, z equal to 2, and all the coordinate planes, then what I'll have to do is, if I want to work out the right hand side, I will have to note down all the 6 surfaces. Okay, and here I have noted down all the n hats. Now, all the 6 surfaces, if you look at them for a cube, they are parallel to one of the coordinate planes. So therefore n hat is merely minus, like in the case of OABC, the outward unit normal will go down this side, and that is in the direction of minus z axis, so that is minus k hat. Same way FABG, where is FABG? FABG, that is this surface. So the outward normal will be pointing towards us, that is in the positive x direction, so plus I hat, n hat will be plus I hat. Okay, so that's perfectly fine. So here you'll have to perform surface integral over these 6 surfaces. Alright, now what you will need to do is EFGD, this surface you'll have to project onto the xy plane. So for this surface, your ds will become dx dy upon magnitude of n hat dot k hat. Alright, same way for this surface GBCD, you will have to project it onto the xz plane. So ds will become dx dz upon n hat dot j hat. And similarly, for FABG, you will have to project it onto the YZ plane. So your ds for that will become dy dz upon n hat dot I hat. Whereas for the other 3 surfaces, they're already on their respective planes, so you don't have to project them anywhere. You're just going to keep them on their respective planes, and their dx, and in this case, for instance, this is already on the yz plane. So your dx dy, your ds will simply become dx dy upon n hat dot, in this case, minus j hat, which will vanish because the minus sign will vanish because this is inside the magnitude sign. Alright, so this is how you perform the surface integral, that is the right hand side. So it needs a little bit of practice. It's a little tedious initially, but once you get the hang of it, it's worth it. Now the question arises as to how do we do the left hand side. Now you have to ask yourself, what is the curve that is binding or bounding the cube? The curve bounding the cube is a square. So it is like, you can just take a thread and wrap the go once round with the thread along the cube. What will be the shape of that thread? It will be a square. So and that square can be projected onto the xy plane. So if you just project this whole cube onto the xy plane, you will get a square. So you will have to perform the left hand side over this square. So you'll have C1 over C2 over C3 over C4. You'll already know line integral. So this is how it goes with regards to Stokes theorem. This is an easy problem.